In Lesson 3-4, we will discuss how to solve exponential and logarithmic equations. In video 3.4.1, the learning target will be for students to be able to solve exponential equations, unlike the baby pictured here. Before we start solving exponential equations, we need to discuss the one-to-one property of exponential functions. In words, our one-to-one property is for b greater than 0. Okay, the base of our exponential function has to be greater than 0. It cannot be equal to 1. Okay, our base cannot be equal to 1. As we discussed in previous videos, 1 to the first is 1, 1 squared is 1, 1 cubed is 1. So no matter changing our exponent, if our base is 1, our outcome or output is always 1, which stays constant. So if we have a base of 1, we end up with a constant function rather than an exponential function. Now, the one-to-one property says that if b to the x equals b to the y, then x is equal to y, right? If b to the x equals b to the y, that is true if and only if x and y are equal. Okay, this is assuming right here that your bases are the same since they're using b in both exponential functions. B raised to the x is equal to b raised to the y only if our bases are the same, and then that implies x is equal to y. So some examples of that they provide are if 3 to the x is equal to 3 to the 5th, since our bases are equal, that implies the value of x is equal to 5. Since these two exponential functions here are equal and the bases are the same, then our exponents have to be the same. In logarithmic form, it looks like if log of x is equal to 3, then 10 raised to the log of x is equal to 10 to the third. The reason for this is that right here, log of x is equal to 3, so they've made a substitution here that log of x for log of x. So if log of x is equal to 3, then they can substitute for log of x equaling 3. Now, another way we could write this, if we write that exponentially, log of x is equal to 3, that really means 10 to the third is equal to x. Now, if you remember from lesson 3-3, if we have 10 raised to the log of x, since the base on our logarithm right here is base 10, and the base of our exponential term is 10, those cancel and we're left with x. So if you are looking at this here, you could say that right here, these two cancel, and you're left with x equals 10 to the third. Same thing I got here when I rewrote this logarithmic equation in exponential form. Now, in example 1, we're going to solve exponential equations using the one-to-one property. In example 1, part A, we're asked to solve 4 raised to the x plus 2 is equal to 16 raised to the x minus 3. We want to know what value of x makes those two exponential functions equal to each other. Now, the important thing with using the one-to-one property is that our bases have to be the same. Remember that b to the x is equal to b to the y only if our bases are the same, and then that implies x is equal to y. So before I can say x and y are equal, we need to get these bases equal to each other. Now, if you look at 16, and our base here is 4, 16 can be rewritten as base 4. 4 to the first is 4, and 4 squared is equal to 16. So I'm going to rewrite the right side of our equation as 4 to the second power raised to the x minus 3. Okay, so all I've done so far is convert our base of 16 into a base of 4. 4 squared is 16. Now here I have a power raised to a power, and when I have two exponents raised to, or a power to a power here, or an exponent times raised to another exponent, we multiply those exponents, right? From our properties of exponents, if you raise a power to a power, those powers get multiplied. So I still have 4 to the x plus 2 on the left side, but over here I really have 4 to the 2x minus 6. Because this is a binomial, x minus 3 is a binomial, when I multiply them, I distribute the 2 to get 2x minus 6. Now that my bases are equal, we can apply the one-to-one property in that if our bases are equal and the exponential equations are equal, that implies that our exponents are equal. So I now know that x plus 2 has to equal 2x minus 6. And what I'm going to do is solve for this equation for x. So I'm going to collect the x's on the same side of the equation, subtract x. I'm left with 2 equals x minus 6. And to solve for x here, I would add 6 to both sides of the equation, and x is equal to 8. Now, I can always check my solution by going back to the original problem and substituting in 8 for x. So really, I would have 4, I'm going to check my work right here. I would have 4 to the 10th on the left side. If I substitute 8 for x, 8 plus 2 is 10. And over here, I would have 16 to the 8 minus 3, which is 16 to the 5th. So on your calculator, you could type in 4 to the 10th and see if that's equal to 16 to the 5th. And they should be equivalent, which makes x equals 8 your solution. In example 1, part B, we're going to again use the one-to-one property to solve an exponential equation. Here, in this problem, we're asked to solve 1/3 raised to the nth power is equal to 1/81st, or 1 over 81, raised to the 2/3 power. Now, the key thing with using the one-to-one property is that we have to have our bases of our exponential functions equal to each other. So, right here, this is 1/3 to the nth power, but 1 over 81 can be rewritten as 1/3 to the 4th power. The reason why I know it's 1/3 to the 4th, 1/3 to the 4th is equal to 1/3 times 1/3 times 1/3 times 1/3. On top, if I multiply these fractions, when I multiply fractions, I multiply the numerators together. So 1 times 1 times 1 times 1 is just 1. And on bottom, 3 times 3 times 3 times 3 is going to give me 81. So 1/3 to the 4th is the same as 1 over 81. And now what that does is it gives me the same base on both sides. Now, I still have my 2/3 power out on the outside because 1 over 81 was raised to the 2/3 power. So really what this right side of our equation is 1/3 to the 4th and then raised to the 2/3. So I have 1/3 to the nth power equals 1/3. If I apply our power properties here, a power to a power means I multiply those powers. So I have 4 times 2/3, which is really just 8/3. 4 over 1 times 2 over 3 is 8 on top and 3 on bottom. So I get 1/3 to the 8/3. And now since my bases of my exponential terms are the same, that implies that my exponents are equal. So I now know the value of n is 8/3. Now I could go back in to the original problem and substitute 8/3, and on my calculator take 1/3 and raise it to the 8/3, and that should give me the same thing as 1 over 81 raised to the 2/3. In example 1 guided practice, you're asked to solve 25 raised to the x plus 2 is equal to 5 raised to the 4x. I would like you to try and apply the one-to-one property that we have discussed in the previous examples and work out your solution and then choose either A, B, C, or D as your solution and then press submit.